This conference will now be recorded.
Right, let's start today's session. In the last session, we were discuss about multi-threading program in Python. So let's try to continue that multi-threading programming. Yes, this is the last program which I used. Oh, it's not this one. I think I have written. Okay, fine. Here. In the last session, we were discuss about multi-threading program and basic functions. So active count function we use for count the number of threads which are currently running. And also is alive method I'm using. Is alive means whether thread is still executing or not, we will say true or false. And also we use join method. If thread wants to wait until completion of some other thread, then join method also we use. And thread identification number purpose we use ident variable also. This is implicit variable. Okay. Now in today's session, I'm going to show you thread synchronization mechanism. So what is thread synchronization? How to work with that? We will see this. Thread synchronization. Thread synchronization. Thread synchronization in Python. Generally, let us consider this program. Okay. So let's consider this program. In this program, I'm just showing if multiple threads are running exactly, multiple threads are executing simultaneously or parallelly for the same function. Usually we will get irregular output. Look at this. What is the irregular output you will get? So this is exactly from heading import star. Okay, import time also I'm taking. Now coming to this here, in this case, when I try to write a multi-threading program like this, so def f1 function I'm taking. This f1 function I want to call through thread only, but f1 function is expecting some name. I can say here for I in range of 10. So 10 times I want to say, like for example, good morning, and end attribute I'm giving some space here, and time dot sleep of 2 seconds I'm taking, and then after that we are going to print this name only, print name. So this is the f1 function which is accepting some parameter like name. We have to supply the name parameter value for I in range of 10. So we are having the loop like this for I in range of 10. Print good morning, end attribute. I have to display this good morning in the same line only. I'm using time dot sleep of 2 seconds. Time dot sleep of 2 seconds. After 2 seconds, I have to print the name what we supply to the function f1. Let us consider this. T1 is thread. Thread is a class. Target equal to f1. At the moment when I target f1 function for executing this T1 thread through, so this function f1 function is accepting some name. So it is expecting some name parameter. So we have to pass args equals to some name like this. I is the name. T1 equal to thread, target equal to f1. args equals to Sai. The next thread I'm creating, one more thread object I'm creating, target equal to F1 again. Now this time args equals to what actually? Mohan is the name. You know threads will be starts only whenever we start the thread. T1 dot start, T2 dot start finally. So this is the program exactly which I want to discuss. So from threading import star, import time F1 function. F1 function is expecting some name. That is name we have to pass while calling this function. We are calling this function through T1 thread object and T2 thread object also, but every time I'm calling with a different name. So first time I'm calling with name Sai and Mohan, T1 start, T2 start. So here two threads are executing parallelly for the same F1 function like this. Now you can see that's what here, the moment when I run this th1 program. So like this, good morning Sai, good morning Mohan, good morning Sai, like this. Two threads are parallelly running for the same function. So here there may be chance of data inconsistency problem. Yes, and inconsistency. This is completely irregular output. No, it's not going to be correct output. Means not in well structured output. Yeah, star. We have to write star, or else no need to write star. Instead of star, what we can use? Just we can use thread class also like this. Because we are using thread class, this thread class is related to threading module. So from threading module only I am importing this class. Why I'm importing this class? Because I'm using this class into this program. But sometimes as a programmer, we don't aware of that what things need to become, what are the things are there in threading module. Then generally we can go for star. Star is not recommend actually, because if I take star means everything will come from this what from threading module. Everything will be load.
So
But if
you
you are
are
saying that, mm,
so you're
yes,
importing the threading class. You're importing everything from threading class, right?
threading
You
module,
have
that
this
is
threading module.
threading
Yes,
module.
sir.
Yeah.
Mm-hmm.
From that module, I'm importing everything. The
Okay.
moment when I start running my application, my program, immediately threading module, how many functions, how many classes, everything is coming. Everything will be load. But
Okay.
in our program, you may not use all the functionalities and all the classes which is coming from threading module. So right now you can see only one class I am using which is coming from threading module. Because of this one class accessing purpose, no need to import any star. So it can use this also. This is good. So
Okay.
what I
So
am
you
using,
are you are
yeah,
importing a specific class, thread class from this module, right? Threading
yes,
module. Okay.
exactly. So at this time, what will happen? Thread class only will be available for this program, and other things will not be available. It's a simple process. If I use star
Okay.
means
Yeah.
everything will be available, threading module, whatever it is there, it is coming to your class. But we are not using all the things
Yeah.
unnecessarily.
We
We
are
are
just
loading
using
them.
thread, right?
Yes,
Okay.
yes.
Understood. Okay. Thank you.
So here T1, T2 are two threads are there, thread objects are there. My question is T1, T2, two threads are executing simultaneously or parallelly for F1 function. That's what in this process generally what is the problem actually means, we are getting irregular outputs are here. So irregular output means not in regular output. So two threads are running parallelly. So that's what we are expecting, some irregular output. Now you can see sometimes not in regular output here. Completely output is in irregular. But if you want to make the output is regular, then what we need to do means, so simple context. So we can use thread synchronization mechanism. There is a mechanism called thread synchronization mechanism. Why? Because here we are getting irregular output. because both threads are executing simultaneously F1 function. To overcome this problem, we should go for synchronization. In synchronization, threads will be executed one by one so that we can overcome data inconsistency problem. Synchronization means at a time only one thread. At a time only one thread. Synchronization means. So synchronization, how we can apply in Python. So synchronization we can implement in Python in three different ways. There are synchronization techniques are there. One is lock technique. Next one is or lock technique. Third one is semaphore technique. Semaphore, lock, or lock, and then semaphore. These three techniques are available. These are the synchronization techniques we can call it as. These are the synchronization techniques, sir. Using these three synchronization techniques, we can overcome this uh, data inconsistency problems. We can make one thread at a time allowed to execute. So first we will see lock technique. What is the purpose of lock technique, how lock technique will work, and what is the drawback of lock, and how to overcome with the drawback by using or lock also. And difference between lock and or lock also we'll discuss in detail. First we'll see lock. So synchronization by using lock concept. Synchronization by using lock. Synchronization by using lock. So locks is the most fundamental synchronization mechanism. Locks are the most fundamental synchronization mechanism provided by threading module. So we can create lock objects like this. We can create a lock object like this. Like we can create lock object like L equals to, or else we can go for next line, L equals to lock. So here L is what's our object name. You can take any name. Lock is what's our class name. This class is coming from which module? Threading module again. This threading module is there, no? In this threading module only. So locks are the most fundamental synchronization mechanism which is provided by threading module. We can create lock object like L equals to lock. L is a object name. Lock is the class name. A lock object can be held by only one thread at a time. A lock object can be held by only one thread at a time. Only one thread at a time. That means the lock object can be held by only one thread at a time. If any other thread required the same lock, if any other thread required same lock, any other thread required the same lock, then it will wait, then it will wait until thread release the lock, until thread release the lock exactly. Simple. One by one means what? Two threads are there, T1, T2, for example. T1 is acquire the lock already. Okay, T1 is access the lock. But T2 also attempting to acquire the lock. But it's not possible because T1 is already holding that lock, no? When T2 can hold that lock, T1 has to release the lock. Thread 1 should release the lock. So that means in the lock concept, the lock object can be held by only one thread at a time. If any other thread required the same lock, then it will wait until the thread release the lock. First thread, if it is releasing the lock, then second thread can require the same lock again. It's possible. Okay. So this is the important. So one by one. So a thread can acquire the lock by using acquire method. A thread can acquire the lock. A thread can acquire the lock by using what method? Acquire method. Acquire method. Acquire method. Like L dot acquire. ACQUIRE acquire method. At the same time, A thread can release the lock by using release method. A thread can release the lock using what method? Release method. L dot release. L dot release like this. So these are the things. So in thread synchronization, by using lock technique, we need to know about these important points. First point is we can create lock object like this, L equals to lock. In place of L object, you can take any name, not a problem. Second point is the lock object can be held only can be held by only one thread at a time. If any other thread required the same lock, then it will wait until thread release the lock. Until thread release the lock. A thread can acquire the lock by using what method? Acquire method. A thread can acquire the lock by using what method? Acquire method only. So L dot acquire is available here. L dot acquire. And thread wants to release the lock by using what method? Release method. L dot release. Fine. And most important point which I want to cover, this is to call release method. To call release method. To call release method, compulsory thread should be owner of that lock. Compulsory thread should be owner of the lock. Thread should be owner of that lock. Owner of that lock. Compulsory. Means what? Thread should has the lock already. That means a thread should has a lock already. That means a thread should has the lock already. A thread should has the lock already. Compulsory. So if thread wants to release the lock, compulsory thread should has the owner of that lock. Means thread should has the lock already. If not, what will happen? You can see runtime error you will get. For example, this example you can consider. Just I'm taking this example, th2. So imagine this th2 is an example. I'm threading import star. I'm threading import star. I'm taking. I'm threading import star. Now observe carefully. th2.py is executing by main thread only, sir. Because you may get doubts, sir, in this program where is the thread? There is no thread, but main thread is going to execute. th2.py program is executed by main thread. You know that by default in Python, every program executed by what thread? Main thread. So I'm creating lock object like this, L equals to lock. L dot acquire. L dot acquire. And I'm taking L dot release method. And print what? Actually just for confirmation end of the program. This program is executing or not. We have to say that. Now tell me, our program name is what? th2.py. Every program is having internally one thread, that you know, that main thread. So th2.py is having main thread only. It's executing by main thread only, sir. Now from threading, import star is there. From threading module, import star. L equals to lock object. L dot acquire method. L dot release method. So main thread is acquiring that thread and main thread is only releasing the thread. It's okay, fine. That's what I'm telling you. To call release method, compulsory thread should be owner of that lock. Yes, main thread is acquiring the lock. So he's the owner. So owner only can release the lock. That means a thread should has the lock already. Yes, main thread is acquiring the lock. Main thread is releasing the lock. No problem at all. End of the program we got. That means program is executing successfully. Suppose if I try to comment line number 4. Until I am doing this. Line number 4 I am commenting now, sir. L dot acquire. Meaning is what? The main thread is not at all holding that lock. Lock object is there, but main thread is not acquiring the lock. If the main thread is not acquiring the lock, but main thread is attempting to release the lock, that means what? Main thread is not a owner of that lock. So according to my statement, what is that? to call release method, if you want to call a release method, compulsory thread should be owner of that lock, I said or not? Yes. But here main thread is not acquiring the lock. So main thread is not a owner of that lock, but main thread is attempting to release the lock. Look at this, what is the problem again? Runtime error will come. Runtime error. Release unlocked lock. Okay, runtime error is what actually? Release unlocked lock. Yes, it's releasing unlocked lock. No one has the lock, but unlocked lock you are attempting to release. So that's what we got, runtime error. So this is the proof, sir. A thread wants to release a thread wants to call release method. Compulsory thread should has the lock already. That means thread should acquire the lock already. Then only it is possible to release the lock. Otherwise not. Got my point? So this is the important part. Now let's move to in our previous program. In the previous program, th1 is there. th1.py. It's a program. Here same function f1 is there. T1 thread, T2 threads, both threads are targeting same function F1. So multiple threads are running in this program. Usually whenever multiple threads are running simultaneously parallel same function, so we will get irregular output. We are getting irregular output only. So because of threads are executing simultaneously F1 function same. Multiple threads are executing simultaneously F1 function. To overcome this problem, we should go for synchronization, I'm saying. In synchronization, the threads will be executed one by one so that we can overcome data inconsistency problem. Synchronization means at a time only one thread, I said. So only one thread means synchronization technique, how it is possible. Lock technique, or lock technique, semaphore techniques are there. These are synchronization techniques. I'm going to work with first lock technique. So lock is the most fundamental synchronization mechanism. In this lock, the lock object can be hold one thread at a time. If any other thread required the same lock, it has to wait compulsory until release the lock of first thread. So that's what I'm converting this program into simple lock technique through. So I'm creating in this program L equals to lock object. Whenever I call t1.start, immediately t1 is going to be target f1 function. F1 function here it is there. Immediately t1 thread will acquire the lock. And after completion of executing this by t1 thread release the lock. I'm using release method. Now this time we are synchronizing the thread. That means we are allowing at a time only one thread, because first thread whenever it start, the thread is going to be acquire the lock for executing. So when T1 thread will release the lock means after completion of T1 thread execution, it release the lock, then T2 thread can acquire the lock again. Look at this. First T1 only executing the F1 function. After completion of, after releasing the T1 thread release the lock, then T2 thread started. Good morning Mohan, like this it there. So this is thread synchronization mechanism through we are achieving this one by one thread. So we are making regular output, not irregular output here. So one thread at a time I am allowing to execute, sir. This is with clear picture. So we got this output clearly, sir. Got my point? So this is lock technique is there. We are using lock object. So T1 thread whenever it is attempting to call this F1 function, immediately T1 thread is acquiring the lock. Once T1 thread is acquiring the lock, in the middle also T2 thread is sometime it is going to be attempting to acquire the lock. It has to wait, sir, because T1 thread should release the lock. Once T1 is released the lock, then only T2 thread can start execution of F1 function. Again, it will acquire and it will release like this. Like this, you can include any number of threads and you can able to manage easily. But though we are using lock technique, okay, thread synchronization by using one by one thread, so we are overcoming this data inconsistency problem. It's okay, no problem. But there is some problem is there with lock technique, sir. That's the reason we have to go for R lock technique. R lock stands for reentrant lock. Reentrant lock, we can say that. R lock means reentrant lock. R lock meaning is what actually? Reentrant lock, we can say that. Reentrant lock. R lock is nothing but reentrant lock. Okay. So what is the problem with the lock technique? So why we use rlock, we will discuss. Okay, so what is the problem with lock technique means a simple lock, a simple lock. That means a standard lock. Simple lock means this is only lock. This simple lock object does not know which thread is currently holding that lock. Okay. The moment when we create lock object L equal to lock, this simple lock object or standard lock object does not know which thread is currently holding that lock. In this standard lock mechanism, if the lock is already held by some thread, if some other thread is attempting to acquire the lock in the middle, then it will be blocked. Threads will be blocked. Even the same thread is already holding that lock also, then immediately threads will be blocked, sir. That is the problem. Got my point? What I'm saying? In the simple standard lock object, suppose one thread is already holding that lock. Assume that. In the middle, same thread or any other thread trying to attempting to acquire the lock again, then immediately threads will be blocked. Why it will block? Because the simple lock technique, lock object don't know which thread is currently holding that lock. There is no information with this lock. So to avoid this situation, we can go for R-lock. R-lock means what actually? Re-entrant lock. Re-entrant lock in the sense what? So re-entrant means a same thread can acquire the lock again and again. If the lock is uh, held by one thread, that same thread can able to acquire the lock again and again. It's possible. But other threads not possible again. Same thread only, it with any number of times, the thread can acquire attempting to acquire the lock, it's okay. But any other threads in the middle attempting to acquire the lock, then that also will be blocked actually. Okay, let's see this. How re-entrant lock will work. What is the problem with lock object? We'll see this. So first example, sir, in which case the lock object will make some problem, especially in the recursion case. Recursion means what? A function that calls itself every time. Example, factorial function, you know that. Okay, let me show you the quick example, factorial function through. I'll show you that what is the exactly problem with lock object and how to overcome this, we will discuss clearly. So now I'm taking th3. Now this time you can see this from threading import star and import time is not required, but let's see this. Now I'm trying to def factorial function. Factorial is a recursion function. In this case, I'm showing like n is there. If n equal to 0, then this logic already we have know that. Result equals to what actually 1 are. Else block, then result equals to n into factorial of n minus 1. Then return result like this. Okay, return result. So this is the exactly code, but I'm trying to call this function not directly through thread. I'm trying to create one more what we can say function through. So first before that I'm trying to do what? Lock object how to create. L equals to lock object. Let me see. And I write same program factorial of finding program with lock object. What is the problem? Why we use what we can see re-entrant lock we have to use. Here L dot acquire after completion of task, L dot release actually. Okay, now this I'm going to call with separate function. Def result is my function name of n. This function only I'm going to execute through thread only. When we call this here print, just I'm taking the factorial of n is factorial of n is comma factorial of n I'm passing. This is our main function, sir. This function only I want to call through thread. T1 is a thread object, equals to thread is a class, target equals to what function I want to call, factorial function. Target equal to result function I have to use. Result, comma. This result function is having parameter or not? Yes. So that's what parameter passing in the thread object args equals to n, 4 comma I'm passing. T2 equal to thread object, target equals to what I'm taking, result function again, args equals to what actually, 5 I'm taking, 5 factorial. T1 dot start. If you want to work with threads, compulsory how to use start function. Start. T2 dot, I'm taking start. Now observe carefully. So we are using normal factorial function. Factorial function, you know that. Factorial function is a recursion mechanism. Recursion means what? Recursion means a function that calls every time itself. A function that calls every time itself is called recursion. So observe here, this result function through I am calling factorial function. So first let me explain what's going to happen here. So when I start T1 dot start method, T1 is a one thread. T1 thread is going to start. T1 thread through which function I am targeting, result function I am targeting. I am passing result function what value? Fourth value, 4 value, number 4. So n value here 4 only, sir. N value 4. So here n value 4 means, so immediately line number 15, the factorial of 4 is factorial of 4. So here we are calling the function factorial of 4 through what? T1 thread. T1 thread you are calling the factorial of 4 means immediately it will call function or not? Factorial of 4. So lock object already there. We are calling T1 thread through n value 4. Then T1 thread is acquiring the lock or not? Yes, it is acquiring the lock. After that 4 equal to 0, not correct. It will go to else block. Result equals to 4 into factorial of 4 minus 1. Factorial of 4 minus 1 is what actually? 3. Factorial of 4 minus 1 means what? 3 only. But factorial of 3 purpose, again the same function is going to call itself or not? It's going to back. It's going to back in the sense what? Same T1 thread attempting to acquire the lock again or not? Yes. Then in this case threads will be blocked. Okay. Why? Because this normal standard lock object doesn't know which thread is currently holding the lock. That's what it will allow. Already one of the thread is acquiring the lock. One more same thread also is attempting to acquire the lock. It will allow that. But unfortunately, same thread cannot acquire the lock because without releasing the lock, that's what it is getting what actually threads blockage. Okay, yes. 4 value we are passing now here. Now you can see args equals to 4. T1 equal to thread. Yes, here we are passing the value. T1 thread through we are passing the value to the function n value 4. T2 thread through we are passing the value that is 5. I am passing the value n value. Factorial of n means factorial of 4. So T1 thread through we are passing the 4 value, factorial of 4, and immediately it will go to here and n value 4. Immediately T1 is acquiring the lock. When T1 is acquiring the lock, it will proceed. 4 equal 0, not correct, else block it will go. 4 into 4 minus 1, 3. Factorial of 3 purpose, again it has to call the same function itself. In the process of factorial function is calling itself every time. Again T1 thread also attempting to acquire the lock again and again multiple times. But this is the normal lock, standard lock object. But this standard lock object don't know which thread is currently holding that lock. Same thread also holding that lock again and again. Threads will be blocked. We will not get any output. Look at this. Are you getting any output in this program? Just you will see this. No output. How long time you wait? Just wait. Nothing. Here threads are blocking. Yes, right now it is threads are blocking now. There is no output. Okay, that's what we can do. We can go for R lock. Simply we can use R letter I'm using. That's it, R lock. R lock I'm using now. Yes. The moment when I try to use R lock, you can see stop debugging. So once we stop debugging and run it now. So let's see this now. This time we are getting output here. Because of R lock, we are getting output. Note this point. If I remove R lock again, then run this, threads will be blocked. R lock means what? Reentrant lock. Means same thread can attempt to acquire the lock again and again. But simple lock means not allowed. In simple lock object, a same thread is attempting to acquire the lock again and again, threads will be blocked. But at the moment when I use R lock means what? R lock means reentrant lock. A thread, same thread, T1 thread is acquiring the lock already. Again, T1 thread also can acquire multiple times lock already, can acquire multiple times lock again and again because we are using factorial function. It's a recursion. Recursion means a function that calls itself every time repeatedly. So that's what we can use R lock technique here. So that advantage of R lock is this one. So R lock means reentrant lock. Okay, reentrant lock means a single thread already which is acquiring the lock. That same thread can attempting to acquire the lock again and again. That is possible. That is R lock. So reentrant means a thread can acquire the same lock again and again. In the R lock technique also, other threads are attempting to acquire the lock, then it will be blocked. Same thread, it's okay, no problem. Same thread, any number of times this can be acquire the lock again and again. But other threads should not acquire the lock again and again in this R lock technique also. So especially in the factorial case, so lock technique is going to be fail, means it will not allow, threads will be blocked. And R lock technique will be work here in the case of factorial case. So this is reentrant lock, we can say that. So what is the difference between lock and R lock means this is exactly, sir.
So
Now,
the lock
uh,
will not allow for the repetition, you mean?
yes, exactly. I mean,
Okay.
repetition, single thread, already one thread is acquire the lock. Same thread cannot acquire the lock in the lock concept. R lock, it is allow. R lock will
Okay.
allow that. So difference
Thank you.
between lock and R lock means lock object can be acquired by only one thread at a time. Even owner thread also cannot acquire multiple times in the lock object. Lock object can be acquired by only one thread at a time. Even owner thread also cannot acquire multiple times. But whereas rlock object can be acquired by only one thread at a time, but owner thread can acquire same lock object multiple times. Just now I have seen like I have shown same T1 thread is attempting to acquire the lock again and again in the rlock technique. So lock mechanism, standard lock mechanism not suitable to execute recursive functions, and this rlock mechanism best suitable to execute recursive functions. So lock object will take care only locked or unlocked, and it never takes care about owner thread and recursion levels. But rlock object will take care whether locked or unlocked, and owner thread is owner thread information also recursion level clearly. So these two synchronization techniques are there. And third synchronization technique is also there, that is called semaphore. Synchronization by using semaphore. Semaphore object is simple. Suppose in the lock case or lock case, what we use are in the lock and or lock case. In the case of lock and or lock, at a time only one thread is allowed to execute. Only one thread allowed to execute. But sometimes, as per my requirement, user requirement, at a time particular number of threads are allowed to execute, allowed to access. Suppose 10 threads I want to allow at a time, single execution. Every time 10, 10, 10 like this. So then we can use semaphore concept. Semaphore object, how to create means s equals to semaphore. And here it is, I'm taking counterpart here, counterpart value. So s equals to, for example, semaphore is my class. counterpart I'm taking 3. Meaning is what here? Counterpart 3 means 3 threads allowed to execute at once. At a time, how many threads are allowed to execute means 3. So single execution 3 will be executed. 3 threads like that only. This is called counterpart value. But sir, what happen if I don't use any counterpart value here 3? So then counterpart value is what actually by default 1 only. If I don't mention any counterpart value in this bracket, and the default counterpart value is what, sir? 1 only. 1 means at a time only one thread allowed to execute. This is counterpart. So s equals to semaphore, and out I'm taking counterpart value 1 only. So 1 means default 1. If I say 5 means 5 threads allowed to execute at a time. So semaphore can be used to allow multiple threads at a time if you want to execute. So semaphore is an advanced synchronization mechanism. So here counterpart represent the maximum number of threads are allowed to execute. So you can decide as a programmer how many number of threads are allowed to access simultaneously. The default counterpart value is what actually 1, sir, 1. And next, whenever thread executes acquire method, then counterpart value will be decrement by 1. Every acquire method calls counterpart value decrement by 1. Every release method counterpart value increment by 1. Every acquire method counterpart value is decrement by 1. Every release method counterpart value is increment by 1. Every acquire method counterpart value is decrement by 1. Every release method counterpart value is increment by 1. So this is the case. Because suppose counterpart is 5, sir, means my requirement is at a time I want to allow 5 threads to run. So one thread already acquired, remaining 4 threads. Second thread already acquired, remaining 3 threads. Like this, counterpart will be decrement by 1. Whenever thread release the lock means again it is re-attempting to lock. So every release method counterpart will be increment by 1 like this. So let's see this. This is semaphore technique. Semaphore technique. Same example will go to previous example here, and this example through I'm explaining this semaphore object how it will work. For example, look at this. I'm creating semaphore object s equals to semaphore counterpart. I'm taking 3. So s dot acquire method. S is semaphore object. That's it. S dot release method. But I'm taking actually multiple threads here wantedly. Few more threads I'm including like this. Total 6 threads I'm including now wantedly. And total 6 time we have to start it here like this. So T1, T2, T3, T4, T5, T6 like this. Next here T1, T2, T3, T4, T5, T6 like this. And now I'm trying to say this remaining names I'm taking like this. So total number of threads are how many are there, sir? 6 threads are there. Look at this. Total 6 threads are available here. In this 6 threads, so my counterpart value of the semaphore object is what? 3. So the moment when I run this, every time 3 will run. If I don't use this one, but default counterpart value how much it is? Now we can see every time semaphore is 1 only. Semaphore object 1. Default counterpart is 1 only. If I don't use 3, for example 3 means, now look at this, at a time 3 are going to be run. 3 plus 3 plus 3 plus 3 plus 3. 3 threads are allowed to execute now. So sometimes, yes, it is compulsory, sir, in reality. So because at a time, do you want to accept how many requests from the user? So 3, 4 requests at a time. How many number of requests you want to accept also you can decide. If I say 4 means my counterpart is 4 means, now this time you can see 4 threads are allowed to run now this time. 4, 4, 4, 4 it will come. Yes, we can run any number of threads, not a problem. How many you have? There is no, by default 5 not. No default 5. Default number is 1 only. You can include any number of threads, not a problem. So if I don't use counterpart here, okay, you can, if I don't use counterpart here, then default is what? One thread at a time. Default is one thread now. Now you can see one because I have not decided one. So only one thread at a time it is running. But sometimes I want to allow 3 threads, sometimes I want to allow 4 threads, sometimes I want to allow 6 threads. So then you can use the counterpart number like this. So this concept is called semaphore concept. Semaphore is allowed to maximum number of threads at a time to execute. So according to your requirement. So to handle this, we can go for semaphore object. But there is one more object is there that is called bounded semaphore. What is the difference between normal semaphore and bounded semaphore? I will tell you. Look at this. See, bounded semaphore is the best option to avoid programmatic mistakes. Let's see this bounded semaphore, how it will work. Bounded semaphore is there from threading import star. So bounded semaphore means in the normal semaphore object, how many times you are using acquire method, that many times only you have to release actually. But you can also use multiple release methods. So multiple release methods also possible. So normal semaphore is an unlimited semaphore which allows to call release method any number of times to increment counterpart. The number of release calls can exceed the number of acquire calls method also. For example, you can see here it's a normal semaphore. S equals to semaphore of 2 I'm taking. So s dot what I can take acquire method I'm taking s dot acquire again s dot acquire seq s dot acquire 2 times acquire. But how many times you are releasing? Look at this s dot release s dot release s dot release. Many times we are releasing dot release, but there don't be any problem actually. How many times you are releasing? Not a problem. Now just I'm printing end of the program here. End of the program. Now this time you can see what will happen. Is this giving any error? No error. So even in the normal semaphore object, okay, so we are using 2 times acquire method, but many times we are releasing too many times releases are there, 4 times. It is valid because it is in normal semaphore. In normal semaphore, we can call release method any number of times. So that means in the normal semaphore, a release method can increase the acquire methods number of acquire methods also. So to avoid this programmatic mistakes, but we should not release many times like this. To avoid this programmatic mistakes, when we can go for bounded semaphore. Bounded semaphore is exactly same as semaphore, except that the number of release method calls should not exceed the acquire method calls. Means here I'm taking bounded semaphore right now. Bounded semaphore. Now bounded semaphore is what is going to happen. Where did you declare number release call method? See see, this is 4 releases are there, no? 4 times release method is there. How many times acquire method? 2 times. But is this matching? No matching. Even no matching, normal semaphore it will allow, sir. Acquire method 2 times are there, release method 4 times are there. That means release method is exceeding the acquire method calls, number of calls. 2 times only you acquire. Why you are releasing many times? Not required. So that's what, if I use semaphore, it won't give any error because it is unlimited release method possible. So that's what we are using, what actually bounded. Bounded semaphore will not allow like that. Bounded semaphore means what? It's a clear semaphore which will be accept only number of acquire methods calls matches with number of release method. Your number of acquire methods 2 only, it should match with number of release method 2 only. But unfortunately here 4 release methods are there, 4 methods are there. It will give you error, value error, semaphore released too many times. Too many times means 2 times acquire method is there, here multiple times release method is there. This will not allow. So we can avoid programmatic mistakes simply by using bounded semaphore. By mistake, if you call many release method, we can rectify by using bounded semaphore. It's not possible with normal semaphore. Okay. So to prevent simple programmatic mistakes, it is recommended to use bounded semaphore compared to normal semaphore. In normal semaphore, by accidentally, if we use acquire method 2, release method 5 also, it's okay. But in the bounded semaphore, immediately it will cross verify how many acquire methods are there. Is that matched with the release methods are there or not? It will check and it will stop you. So this is exactly semaphore, bounded semaphore, how it will work like this. Okay. So this is about threading concept in Python programming like this. So this is threading, and remaining topics are there. No? So whatever decorators, generators, and assertions, logging, that are simple topics. So maximum and pandas, matplotlib, data visualization, data analysis also topics are there. We'll finish as much as possible. So then immediately we'll announce a batch of Django. Mostly uh, tomorrow, day after tomorrow, classes will be there for this, and mostly in the next week in the middle, we will try to what we can say announce new batch of Django. The timing is 6:30 only. I'll try to show you. Now, what is your program? Just let me show you. What's the problem with this? So here it is indentation problem again. We have to go for like this. This is correct. Here we have not imported. We have to keep this one EID like this, ename,
Okay.
not like this. And import CSV, you missed this. It's working fine now. What is the thing? Right row means here what actually? This is not your employee ID, employee name like this. So these are the heading rows, columns, and you can decide number of employees, how many you want. Each employee we can accept at runtime. The value will come 101 name something. That value is only we are applying. This cmp.csv file will be create and it will store that. You can check it. This is correct program.
Okay. Thank you for correcting.